LeetCode 3558. So we are given an undirected tree with n nodes labeled from 1 to n and the root of which is 1. The tree is represented by a 2D integer array called edges, the length of which is n minus 1, where edges of I are two elements ui and vi that indicate that there is an edge between node ui and vi. Now, initially all edges have a weight of 0 and we need to assign edges the weight that could either be 1 or 2. And the cost of a path between any two nodes u and v is the total weight of all edges in the path connecting them. So we need to select any node x at the maximum distance and return the number of ways to assign edge weights in the path from 1 to x such that the total cost is odd. So I'll explain. So this is the given input. So it says there is an edge between 1 and 2 and it is an undirected graph and this is the root. Then it says there is an edge between 1 and 3. Okay. Again it says there is an edge between 3 and 4 and another edge between 3 and 5. My task is, and initially these weights are all set to 0. Okay. So now I can put the weights over here as 1 or 2, here as well 1 or 2, 1 or 2 followed by 1 or 2. Okay. My task number 1 is to find the maximum depth. Okay. My task number 1 is to find the maximum depth. Okay. So over here, as we can see, this would be the maximum depth. That is it consists of two edges, or this one could also be the maximum edge. So my task number 1 will be to find the maximum edge. Since this is given as a 2D vector, we can convert this into an adjacency. We can convert this into an adjacency list. So yes, so my first task is to convert this given input vector into an adjacency list, followed by finding the maximum depth. Now to find the maximum depth, assume we got the maximum depth. So in this case, the maximum depth, so assume the maximum depth, that is number of edges, is equal to 2, in my case 1. So I have edge number 1 and I have edge number 2. So I can give value to each edge being 1 or 2. So I give value 1 and 1. This is case 1, 1 and 2, 2 and 1 and 2 and 2. So they are asking me to report the number of possible ways in which I can get an odd sum. So over here, sum is 2, sum being 3, sum being 3, sum being 4. So a key observation would be, so over here there are two edges, edge 1 and then comes edge 2. So in this we can fill the first edge with value 1 or 2 and the second edge with value 1 or 2. So the total number of ways will be 2 into 2, that is 4. So assume another case. So I have got 3 edges. So my edges is equal to 3. This is my case 2. So this is edge 1, edge 2 and edge 3. So I put 1 at all places, 2 at the third, and then comes 2 at this position. Okay, so I've got 4 elements. Now I put 2 at all positions, followed by, so this is my total ways. So in this we can see we have got 3 edges. In this I can put value 1 and 2. In this I can put value 1 and 2. In this I can put value 1 and 2. So my total possible ways would be 8, that is 2 raised to the power 3. Okay, this sums to be 3, this sums to be 4, this is 4, this is 4, this is 6, this sums to be 5, this is 5 and this is 5. So number of odd terms are 4. So one key observation is, if we have, so I have got the number of edges being x. So my total ways would be to fill this edge. So I've got this up till x, that is edge number 1, edge number 2, edge number 3, 4 and so on up till edge number x. So the total possible combinations would be 2 raised to the powered x, out of which my odd ways would be 2 raised to the powered x by 2, that is 2 raised to the powered x minus 1. Okay, so as we have seen, the story points being we convert the given vector into an adjacency list. Okay, and then we find the maximum depth. This is step 1. Step 2, we find maximum depth in this graph type structure. So for this we could use recursion. Okay, so for finding this we could use recursion. Following this we report following this we report now in this case, if we get my value as x, so we report 2 raised to the power x minus 1 as my answer. That is, in these many ways we can get an odd sum. So I'll code it in Rust so it will become more clear for you. So over here, my first task is to convert this 2D vector into an adjacency list. So I create, say, let my mutable adjacency list. So I use a hash map for this. So my first element is simply my edge, and the second being a vector of type 32 integer which stores its neighbors. So this is, I created an adjacency list. Now for edge that belongs to edges, that is given to us, the 2D vector. So I get my first element, that is let u is equal to edge of 0, followed by let v is equal to edge of 1. Then in my adjacency list I create the entry in my u if this is already present. If this is not present, I create an entry. So I do vector new and then push this back into the vector. Similarly, in the adjacent in the corresponding list of v, we push back u. Okay, so at this step we have successfully created the adjacency list. Now I find the max depth. So my max depth, I would be creating a function called get max depth, in which I pass on this adjacency list followed by my start node, or maybe my the greatest parent node, sorry, the starting node. So over here it says the root node is 1, so I pass the root node as 1. Since it has got no parent, I put the parent value as -1. Okay, and after receiving this I create another function wherein I would be calculating the power. So this would be 2 raised to the power max depth -1, and I need to report it as an integer of type 32. Okay, so let me create my function that's called maximum depth. Okay, so I have this function called get max depth over here. So it takes in input the adjacency, this over here, adjacency list. Okay, and it takes it by reference rather than creating a new one, and it takes the node, this is of type 32, followed by the parent. So parent is also of type 32, and this over here would return me an integer of type 32. So I initially put my depth as 0. Now what I do, so I go on and check for the neighbors. So if I do start for the neighbors, so if my neighbor is already visited, then I skip this. I don't need to travel again to this. Okay, so for I do neighbor in neighbors. So if my neighbor is the parent, I don't need to count this as my depth, so I put continue over here. Then I put depth as the maximum value of, and call this recursion function. So one second, so I have self and then I call this get max depth function with my adjacency list, neighbor and node, and I do a +1 over here. Okay, so and after coming out I return depth over here. Now I need to create the power function. So for creating the power function, we use constant mod. This is of type I64, and I say 1e9 plus 7. So this would be denoted as this. Okay, now I create the power function. In this, it takes the base as input, which is of type 64, and then exponent, which is of type 32, and it returns an integer of type 64. So if we have reached the exponent, so this is my base case, so if my exponent is equal to 0, in this case I return 1, since anything to power 0 is 1. Now I calculate half. So my half would be, I call this function recursively. Okay, so I send the base followed by, now my exponent is reduced by, that is, it has been divided by 2. Now I create a result which would be half multiplied by half, and then we take the mod of it with the mod declared previously. Another thing to notice is if my exponent is odd, that means we have calculated one less time. So my result would be result into the base, and then I take the mod of it with the given requirement. Since I have used hash map, so what I'll go ahead and say is use standard collections called hash map. Okay, let me run this code. So for the get max depth function over here, this would be a comma, sorry. So over here, if my exponent is odd, so in that case I would have to multiply the result with the base again. Okay, so if my exponent mod 2, this seems to be fine over here. Sorry, I need to return the result over here. I haven't returned the result. So yes.